What is EtherChannel? So imagine this topology. We have two switches and one cable connecting them. This is great, but what if we want more bandwidth to flow between these two switches? Now you might be thinking, that's easy. Just add more Ethernet cables that connect them. Add like 4 or 5. And that's kind of right. Let me explain using PingMyNetwork, and then we'll actually configure this on real Cisco switches. Simply adding more cables between the switches won't work because of something called STP, or Spanning Tree Protocol. If you don't know what STP is, I'm going to make a video on that soon. But for now, all you need to know is that it blocks redundant links to prevent loops. And when we add more cables between the switches, every extra cable is technically a redundant link, meaning that it's not really required. When STP notices this, it blocks every single redundant link except for one. Or I guess it blocks all redundant links. It only leaves one link up. The only way to enable another link would be to shut down the working link so that another link can take over. Well, that's not really helpful when we're trying to get more bandwidth. This is where EtherChannel comes in. This huge limitation is solved because EtherChannel allows you to take multiple physical links into one big logical link. So if we have the same topology, but we use EtherChannels, STP won't block the redundant links because it really only sees one link. So this is how we're able to increase the bandwidth and redundancy of trunk links connecting switches. So let's do this question. Why does STP block extra physical links between the switches? Prevent loops. Submit. Yep, and yeah, as I said before, STP is used to prevent layer 2 loops. I'll make another video talking about STP later on, but it requires a whole video, if not multiple videos, to explain. So there's actually 3 different ways to configure EtherChannel on a switch. The first one is static EtherChannel. The second one is port aggregation protocol, or PAgP. And the third one is link aggregation control protocol, or LACP. PAgP and LACP are able to automatically negotiate which interfaces can form a bundle, whereas static EtherChannel, as you can probably guess, requires you to manually group interfaces on both switches. So within PingMyNetwork, we can actually practice our switch configurations. So let's say we want to configure this topology. So we want to configure an EtherChannel with 2 links, G00 and G01 on both switch 1 and switch 2. We can start the CLI. We go interface range G0/0 to 1. So this is just so that we can configure G00 and G01 at the same time. Then we use the command channel group 1 mode on. The keyword on here means that we're using static EtherChannel. And channel group 1 is just telling the switch, I want these interfaces to be in channel group 1 or in this EtherChannel. And then we can exit out of here and we can actually configure the EtherChannel as a whole. If we go interface port channel 1, we can configure this as switch port trunk encapsulation dot 1Q, switch port mode trunk. It looks like the VLAN we're allowing in this topology is VLAN 50. Switch port trunk allowed VLAN 50. There we go. So this can actually be very confusing because look, after we did interface range G00 to 1, we use the command channel-group 1 to add those interfaces to an EtherChannel. But to configure that EtherChannel, it's interface port channel 1, not channel group. And then later on, we're going to be using the command show EtherChannel summary. So we have 3 different names for basically the same thing. We have channel group, port channel, and EtherChannel, all basically the same thing, but used in different configuration commands. And on switch 2, you do the same thing, but let's just skip that for now because we're literally doing the exact same thing. And we're going to do it on the real switches later. So another question. What logical interface is created when you group physical links in an EtherChannel? And the answer to that would be port channel, I'm pretty sure. Port channel. There we go. As I mentioned like a couple of seconds ago, another really useful command when trying to troubleshoot EtherChannels is show EtherChannel summary. So let's go ahead and try that. Show EtherChannel summary. And whoa, I leveled up. And you can see that our port channel is here, which is port channel 1. We have the SU flags, which is S stands for layer 2 and U means it's in use. And our ports have the P flag, which means it's in the port channel. Who could have guessed? So before we actually configure this on the real switches, I just want to give another huge shout out to PingMyNetwork. They've made this platform that makes studying for the CCNA fun and satisfying. Like, they have a leaderboard for you competitive people. And right now until February 12th, you can use the code giveaway30 for 30% off. Or after that, if you missed it, you can use code Paulo for 10% off. So now let's actually configure these switches. Okay, so this is going to be our topology. We have two of our switches, and between these switches, we're going to configure a 3-port ether channel. And these 2 ports over here are connected to my 2 PCs. And in the end, we should be able to ping from one PC to another. Obviously using 3-port ether channel just for a ping is kind of crazy, but you know, it's just for a lab, so yeah. Okay, so we're console into the first switch right now. So let's just, oh, hold on, let's check device manager. I'm pretty sure it's COM6 because I was just doing this earlier, but let's just double check. Yep, COM6. So COM6, and let's leave the speed 9600. No. So enable, configure terminal. And the first thing we should do, since this is literally just a blank switch, is create a host name. So host name switch1. And we should also create a password, but I'm not gonna do it. I'm not gonna create a password because it's just inconvenient for labs. I don't know. And then let's create a VLAN 10. This is the VLAN that we're gonna put our PCs in. Let's just name it Paulo VLAN. Yep. Since my PC is connected to, oops, exit. Since my PC is connected to the first port, let's configure the first port to VLAN 10. Switch port, mode access, switch port, access, VLAN 10. All right, starting from now on, I'll use the full version of the command because if you've never configured a switch before, this would probably confuse you. So I'll just use the full commands actually. Now let's configure the 3 ports that we want to put into our ether channel. Int range G1/0/46 to 48. Oh yeah, and we're creating a LACP ether channel actually. I didn't even mention that yet. And one thing to note is that LACP uses the terms active and passive. If switch 1's ports are configured as passive and switch 2's ports are configured as active, an ether channel will be formed. Also, if both switches' ports are configured as active, an ether channel will be formed. However, if both switches' ports are configured as passive, no ether channel will be formed. This is for LACP. For PAgP, it's basically the same concept, except it doesn't use active and passive. It uses auto and desirable. So auto would be passive and desirable would be active. It's really the same concept, but just a different protocol. Channel group 1 mode active. So we created a port channel, exit, and then interface port channel 1. And now we can configure this as a trunk. So switch port trunk encapsulation .1q, switch port mode trunk, switch port trunk allowed VLAN 10. So we're only allowing VLAN 10. If we use the command show ether channel summary, we should be able to see our thing, our port channel. Yep. So we can see, why is it up though? It shouldn't be up. I thought it would show down because we haven't configured the other switch yet, but I guess it shows up. So, all right, let's just go to the other switch and configure that with the exact same configurations, except for hostname. Switch to, okay, so that's why. The reason why the ether channel showed up on the other switch is because I didn't erase the config on this switch. So I'm gonna do that real quick. Write erase, delete, flash VLAN .dat. While we're gonna wait for this to reboot, on the switch, I accidentally did the command like a couple of weeks ago. I accidentally did the command delete flash because I was trying to delete flash VLAN .dat, but I forgot the VLAN .dat part. So I deleted the flash and it just erased the image off of the switch. So the next time I reloaded the switch, there was nothing to boot from. So I had to learn how to re-image, I don't know how you call it, re-image or grab the image from a TFTP server for my laptop, which is so annoying. Okay, so since this other switch is still reloading, if we do show ether channel summary, it should show that it's down. Okay, there we go. See, SD. D stands for down. The ports don't have the P flag, which is usually bundled in port channel, but they have the D flag because they're down. They're down because the other ports they're supposed to be connected to on switch 2 are down. Once we configure those ports as LACP ether channels, this should show SU again, as we saw earlier. It should mean layer 2 up, and these ones should show P, bundled in port channel. Okay, so now we're in switch 2. It's just a fresh switch. Let's do the same configurations. Enable configure terminal, hostname switch 2, VLAN 10, name Paulo VLAN, interface G1/0/1, switch port mode access, switch port access VLAN 10, int range G1 0/0/46 to 48, channel group 1 mode active. We can actually configure this as either active or passive because the other switch is already configured as active. So either way, whether this is active or passive, the ether channel will be formed. So let's actually test that out. Let's make this passive. It should still be formed. Exit. Now let's configure the port channel. Port channel 1, switch port trunk encapsulation .1q, switch port mode trunk, switch port trunk allowed VLAN 10. And that should be everything. The ether channel should be good now. Let's do, show ether channel summary. There we go. The port channel's up. S means layer 2, U means up. And the ports have the P flag, which means they're bundled in the port channel. This means everything should be good. So now let's try to ping my MacBook. My MacBook has an IP address. Actually, what is the IP address? MacBook has an IP address of 10.0.0.3. I'll show you guys the IP address of the Windows laptop, 10.0.0.2. So let's go command prompt, ping 10.0.0.3. And yep, we're able to ping. This means our ether channel worked. If you guys want to watch another video, you can click the link on the screen right now. If you want to subscribe, you can click the other link on the screen right now. And I'll see you guys next time.